Thank you. Okay. Students, welcome to, this is Form 3. This is Form 3 physics. I'm trying to navigate to the, let me see. Okay, I hope you can be able to see my screen. Then I'm aware that you cannot talk because you are already muted. It is good so that for us to have discipline in class. So it will allow us to stick to that so that we move as a team, and in case there is something that will require to maybe to ask, you can do it in the chat room, or maybe you can still make a follow-up after the lessons so that you can talk to the teacher. Good morning, I'm Teacher Libendi. For those who don't know me, I can only have 143 out of the 800, meaning that people are still logging in. So maybe you can give them some, maybe 4 minutes. It's already yeah, we can start at 9:15 so that at least we get the numbers for us to be able to start together. So as you prepare, today we are doing physics, and my interest is in paper 1. Keeping in mind we did an exam that most of us we did well, but again a small number of us again we didn't perform very well. So we are here to support you so that you can be able to understand those areas which you didn't do well and how you are supposed to respond. I'm not going to revise a paper that you did, but I have a sample of questions from this is Mokasa joint exam that they did this year. That is a group of schools. And remember, we are also headed there, the joining of the association. So we need to start getting ready for this kind of questions, which are tailored with the examiners, because it is the way to go. And moving forward, we'll be getting papers being set by a group of people or a group of examiners, then we be subjected to them so that we can respond and give the correct answers. So let's wait, then I'll be taking you through that paper. So I'll request that kindly wherever you are, you can get somewhere to write. I forgot to share the paper. You can get somewhere to write, especially the points you'll be checking through, so that you don't again just listen without writing. I think that will be okay. Check on the numbers. We have 157. I think we can start because 157 is a good number as we wait for others to join, because those who came in earlier, they were able to keep time. Again, it's no need for us to punish them. So good morning, class, and let us start on our today's physics lesson. As I had introduced earlier that I'm Teacher Libendi. I know some of you maybe have not met you, especially in our different classes. I do teach Duke and Michigan. I think those are people we've interacted. In Form 2 paper, I never taught you in Form 2 because you are still small. Now you're in Form 3. I'll be taking you through this good stuffs. So we are going through this paper. This is the Mokasa joint pre-mock paper. I'm also going to blend with the Maseno so that now we have the two papers together. The first question here is, a student was asked to measure the diameter of an nichrome wire as 0.36 millimeters. On the space provided, draw the micrometer screw gauge reading, micrometer screw scale reading. Now, I want to tell you, students, that today's physics of today is really changing in the way questions are tested. I know we are used to getting a diagram, then you just read the values. Right now, the examiner has given the statement. He wants you, or he or she wants you to draw the diagram. It's like a reverse process. And most of us here, we've done income tax reverse process, and now this is where we are even in physics. So what I need to do here is I need to check on the main scale reading, and scale reading I can see it is 0, and then 36 can only arise or emanate from the vernier from the thimble scale, and therefore the thimble scale is given 36, which is now you multiply by what we call the least count. I know you know it, which is 0.01. When you do that, then you get 0 plus 0.36, total giving you 0.36 millimeters. So for my sketch, this is what I did. I did the analysis in a brief, and I was able to come up with the scale. And remember, anything that you ask to draw in physics, if it's a straight line, use a ruler. If you use a ruler, then you get a very nice diagram. Even if the word is sketch, don't sketch using freehand. Use a ruler, and then there must be uniformity. In fact, during marking KCSE, there's a word that we use that let the diagram of the learner be workable. The diagram must be workable. The workability of the diagram is a must for the learner to get the answer for the mark for the diagram. So when you are sketching also, make sure that you follow that so that you get it well. So I'll give you time now just to copy that question, to copy that answer. I'm hoping that you're able to copy the question well. And then I want you to let us put more emphasis on the marking areas. The marking areas is one of them is the sleeve. Sleeve must be clearly indicated. Sleeve scale, the one for 0. 0 is a must. It must be seen. It must be visible. Then the thimble scale, you can realize that I've not indicated 36, but I have indicated 35 and 40. Therefore, mathematically, in between the scales, you are able to read. So when you are drawing again, it must resemble the instrument that you are also interacting with in the labs. All the ones that you used in the lab, they're indicated 35, 40, 45, 50. We don't have 36 in between or 37 as the marking areas. So you make sure that you draw a similar diagram. So those are the two marking areas which must be very clearly indicated for the learner to get the 2 marks. I think that's okay. So you also, when you check on my working app there, you can be able to see my simple analysis. And this one, I'm calling upon all the students. When you're answering to the question, please try to give the details. Don't just write the answer. Show why where that 0.36 is coming. Tell us that you have that 36 times 0.01. It will now lead to 0.36 millimeters. When you do that, then you're okay. All the marks will be on your side. So the question was carrying 2 marks, and those are the marking areas. We go to question number 2. Question number 2. I also did maybe some sort of, I just looked at how to get an image. But before that, before we go to question number 2, because we are in Form 3, just last year in Form 2, but I know we have a lot of work. Most of us are again forgetting Form 2 work. I decided just to share with you the McNaught screw gauge so that again you remember the features and even the function of each and every part. For example, if you look at it, this is the features of, these are the parts of the screw gauge. You need to know the function of the anvil, the function of the spindle. For example, the anvil is normally used to correct the errors in case it has the machine has an error. We normally adjust the anvil to get that error out. And also remember, it also acts like a jaw. Then spindle is the one that compresses onto the anvil so that you're able to get the diameter for anything that you are measuring. We have the sleeve scale, which in this case acting like the main scale. Then you have the thimble scale, which of course it is rotational. It keeps on rotating, and when it rotates, then it's able to give us the number of complete, is able to give us the number, the second 2 decimal places. This is the values on the sleeve scale are the one that you multiply by 0.01 so that you're able to get the reading. Then we have a ratchet. A ratchet has a very serious work. The function of ratchet is very clear. It is the one that we press or we rotate. Once you hear a crackling sound from the ratchet, it is communicating something, that the pressure is enough. Don't over apply the pressure. So please, when you're using this instrument, avoid rotating the sleeve scale. Rotate the ratchet. When you turn the ratchet will reach a level where it will now produce sound. That sound being produced is a clear indication that whatever you are measuring, that's the end of it you can measure. So you don't need to go to over apply the pressure, which can damage the instrument or even damage the object that you are measuring. Then lastly, there's a U-shaped, of course, for the framing. That is just for the sake of making sure that it holds the anvil into position when you are measuring, so that in between the jaws, that the spindle and the anvil, you can be able to get the object and measure its diameter or any other thing that you want to measure. I will not labor you with with the functions, but I thought of it that it's just wise for us to remember some of the parts of the micrometer screw gauge. Question number 2. This one I give you some, maybe just 1 minute to write. Sometimes you can still take the screenshot so that you are able to follow through. Yeah, so the question is here. These are very common question to many students, starting from Form 1. You must have come across this question, and the way we respond again varies depending on the level of understanding. So today we are here to make it uniform, that we need to understand how to respond to this question because it's a very common physics question. So the diagram below shows a wire loop with a thread tied across it. The loop is dipped into the soap solution such that the soap film covers it as shown. You can see the shape of the thread. It is not a perfect shape. So meaning that it is not under tension. It is not under tension, the string. Then the question is, the region X is now punctured. On the space alongside the diagram, sketch the resulting shape of the wire loop, giving the reason for the shape. Now, when you puncture at that point X, you can puncture with your finger, you can puncture with maybe a piece of a metallic object, and even just introducing a hot metal at that point, you puncture that part, and once you puncture it, then you are going to make an observation. So the question is, they wanted to draw the outcome. And you realize that this is a question that is touching on surface tension. And a question touching on surface tension, you need to be able to explain. And then look at this question is 2 marks. So meaning that you must be able to give a diagram which is correct. That one will be looked at to be an observation. Then you explain why the shape. When you look at it, this is what I did. And when you puncture at the center, then you find it's going to form a very perfect circle. Perfect will be formed. And simply because when you puncture at the center, you reduce the surface tension. And when surface is lowered or reduced, then expect the outer forces net outer force is greater to pull the string outwards towards the container side surface. And then you realize the loop will now become tight. So the observation is as it is. You'll form almost a perfect circle. It may not be perfect, but almost a perfect, better than the one which was before. Then we can now give an explanation. Surface tension is greater all round than the thread then the thread is pulling it radially due to outward resultant force. So the point where you punctured the surface tension reduces. Once it has been reduced, then the string will move outwards to become a perfect circle. I can see some hands are up, but I really doubt if you were able to talk. Kingston, Uhuru, Toshiba. Now, something else that we made a communication last time, we said that when you are joining, you are supposed to join using your school admission. And these people, all those students with the funny names like Kingston, Uhuru, Toshiba, kindly rename your handle so that you are able to know who you are. Because we cannot just you rename. Thank you. Toshiba, you rename, and as Nasenda. 26333. Are you able to speak? Maybe unmute. I'm not sure if you're able to because of the rights. Okay. I think you've not been. Okay, Abdi. Thank you, Abdi, for listening to that. So that kindly students make sure that when you are logging in, you have your correct names or your admission numbers. It is the best thing to do.
Excuse me, Mr. Libendi.
Fine. How are you?
The part you are saying where you punctured the center, may you please elaborate again, kindly?
Okay. Now, let's go back. Thank you very much. So we go back to the question. We look at the string, the shape of the string. Initially, it is not a perfect shape. And it's because it is just placed on the water surface. But when you puncture at the center, what happens is that actually you are disturbing the surface tension of that water. Once you disturb the surface of tension of the water at the center, then it is lowered. Once it is lowered, then on the outer side, which is not disturbed, outside the loop, then you find that surface tension is higher. So because the string is lighter, the surface tension from outside is higher than the inner part at the center, is the one going to pull the string outwards. And because the string is tensioned on both ends, you'll find that it's going to form a very perfect circle. So it is simply because of the surface tension, which is greater outside the loop than inside the loop because it has been punctured. And that's how you're supposed to respond, including the diagram. I hope it is okay.
It's okay.
Thank you, thank you. Good. Class, I want us to maintain that discipline so that in case you have something to say, just raise your hand. I'll be able to, so that we communicate. It's also good. It makes our class lively so that you are able to move on well. Now, something you need to put in mind, students, is that the word broken, you cannot break the surface tension. That one we normally reject during marking. When we get the word, the student said that surface tension is broken. It's not a piece of wood that you can break. So we reject that word. It is not physics. It is not allowed. So that is how it's supposed to respond. And a similar question comes in when you are in a canvas tent, when it's raining, then you touch from inside, you will see the tent start leaking. It's the same thing that's happening there. When you touch from inside, you disturb the surface tension, then water starts leaking into the tent. So it's a similar thing as part of your more knowledge on how to understand this. Question number B. Diana placed her finger on the water as shown in the diagram below. You can see the Diana's finger on the water surface. She's trying to pull it upwards, and you can see the water is following her. Then name the force that lifts the water to the finger. So remember again, between water and the fingers we have forces that exist. When you place your finger or an object on water, there are forces that exist. But when you look at the shape of that force, it is trying to create a curvature. That tells you they're trying to resist another force. So the force that is responsible for the water to be lifted in the finger, it is simply the surface tension of that water, which is a property of water surface, which makes the liquid surface to behave like an elastic stretched skin. So you can see the elasticity of water surface on that diagram. Therefore, the force responsible here, it is simply surface tension and not adhesive force. I know quite a number of you will talk of adhesive force, but I'm saying this one can only be the surface tension because of the shape. Okay. And of course, don't forget about the other forces like adhesive and cohesive forces coming in for capillary action. Again, that is pure physics that we need all of us to understand. Okay. There's a question. Terence, I can see your hand is up. Kindly just unmute and share with us what you have. Terence Gitau. Okay, Terence is taking time. Okay, let's proceed. Let's proceed with the. Okay. So we've already agreed that that's surface tension and not adhesive force. The next question here is this is a Form 1 question. But if you look at the way the question had been tested, a Form 1 may not be able to handle it comfortably. So let's go through it. The diagram below shows a cuboid with the dimensions 20 by 20 by 40 of mass, 5 kilograms. Then the diagram is clear. State and explain how it should be placed on the surface, on a flat surface, in order to exert minimum pressure on the surface. So the examiner here is trying to extract from the learner to see if he or she understands the issue of maximum and minimum pressure. So state and explain how it should be placed on the surface. So you're just supposed to know that when you have a small area, you have a maximum pressure. When you have a large area, you have a minimum pressure. And because they want minimum, then it should be on a surface which is larger. In this case, to be by placing it on a 40 by 20 surface. So you place the cuboid on a 40 by 20 surface on a flat surface. This will ensure maximum area of contact, which of course will correspond to a lower pressure. So the student was to explain that by placing the cuboid with the 40 by 20 surface on the flat surface, which will ensure that there is maximum area of contact. That is it. So this is how the questions are being brought in, and most of us are really struggling to understand those questions. You end up failing simply because you have the answer, yes, but you don't know how to package that answer to give it to the examiner. So it's good that as we keep on discussing, you try and understand different versions of responding to different questions. So students, that is how you're supposed to deal with that. And maybe for those who had prepared, for sometimes I know students are normally good in calculation. So they'll say, I'm waiting for numerical problems to come so that I'm able to calculate. But when you open the paper, you find it's about theory, explain, describe, state. Those are very difficult questions to many students. So from my side, I will encourage you to study. When you read the topic, read to understand. So that when you understand, it is easier for you to be able to bring out the points clearly. Unlike if you don't go to the concept, it's not easy to explain. So read to understand the concept. Okay. Question number 4. Explain the formation of steam at 100 degrees Celsius using the particulate nature of matter. Remember, we've already started looking at the possible KCSE questions. And this paper, most of the questions that we have gone through so far, they are from one topics, but the questions are not direct. Like we expect here, maybe somebody would come ask you, state the temperature, the boiling point of water. But now this is about explain the formation of steam at 100 degrees Celsius using the particulate nature of matter. So here, I don't know if there is, okay, there's no hand, that's okay. So here a student is expected to bring out the particulate nature of matter and the kinetic energy, because when matter or when an atom or particles absorb kinetic energy, they get excited, and more kinetic energy will make them to be freed from the force of attraction they're holding, which are holding them before. So in this case, the particles will gain kinetic energy at 100 degrees Celsius. They overcome the internal intermolecular forces to become what? Steam. So when the kinetic energy provides more force, which is more than the intermolecular forces, then they'll break from being liquid and then they form steam. And that's how steam is formed at 100 degrees Celsius. That's for pure water. So the learner was supposed to bring about more kinetic energy being taken in, and then the intermolecular forces being overcome by that energy. And then the particles or the molecules will change from liquid to gas or steam. 26,755. Yes, your hand is up. Just say. Okay. This. Okay, iPhone 16 Pro Max. I said your name with your name is easier for me. But proceed. $26,333. We cannot hear you. Okay. Then if you're not talking, kindly you mute so that you can move together. So just mute. You can only raise your hand if you want to contribute or to say something, we'll be able to listen to you. Thank you. Vinny? How is this Vendi? Vendi, can you rename your name with the admission number? Or else utatolewa bure? Okay, let's proceed, students. I think we are next. On the next question is this still on Form 1. So question number 5. The figure below shows a simple bimetallic strip used to detecting fire. Then the diagram is as simple as it is. You can see bimetallic strip at the top, then there's a contact iron brass at the top. There's a power source, then there is siren. Siren is actually just like a bell. So describe how the fire alarm works. I wish I was able to get some student to take us through this, just to try and give us a summary how to earn these 3 marks. Larry, you can do that. I can see your hand is up. Okay. Larry is not speaking. 26,333.
Well, when at high temperatures, the iron will expand, whereas the brass will contract. Thus, the iron that has expanded will touch the contact point, making the siren to go on.
Okay. Students, I think you've heard him very well. It's not labeled the name, but I'm unable to get, but I've heard you very well. I'm picking a contradiction there before I give Terence to raise something. When you say that iron contracts and brass expands, it cannot work at the same time, true?
Yeah.
Thank you. So that's just a correction you'll be able to correct. But again, I can agree that when there is a high temperature, the bimetallic strip will expand. But because brass and iron have different linear expansivity, remember again, brass expands more than iron. And in that case, you mentioned that brass expands more than iron, and therefore the curvature will bend downwards. Once it bends down, then to bring the contact. When there is a contact, when it makes that contact, then the siren will ring or the bell will ring. So we can just say when the temperature rises, the metal expands at different rates, then brass expands more than iron, causing the strip to bend downwards, making the contact. So you can just say that one. Then of course that one, the alarm will be on or will ring. So students, that is how you are supposed to respond. And it's also good you share out so that we know we correct you as we move on. And actually, that's how you are able to get it right in the next questions. Okay, good. I'm happy with that one. Let's go to the next question. And this is part of the described questions, which are very difficult. Hapo ndio unapata mtoto anaongea mambo mingi ambayo ni rumors. They talk about rumors. Now, this is where rumors comes in. So please read up the content and be able to give us something good. Let's question number 6. Jane stirred hot tea using a metal spoon and observed that the handle of the spoon soon became warm. State 2 ways through which the heat is conducted to reach Jane. 26. It had disappeared. Larry, your hand is still up. You have something to say? Maybe just one person, then from there proceed. Albert? Okay. So let's proceed. I think maybe they're raising hands without knowing. So students who can try this, who can try to respond to this, state through 2 ways through which the heat is conducted to reach the hand. There is this guy, 26047. 26269. Okay. So students, if you are not going to speak, then you better lower your hand so that we don't have a class that is confused. You lower your hand so that we can proceed. Albert, lower your hand. You've been raising without speaking, so you lower your hand. Let's proceed. We have, there are two ways through which it is. Remember, these are solid and it's a metal, and therefore it has free electrons. That's number one. Oh, okay. I've just received a message that students cannot talk because they are muted. So let's kindly follow through the needs. Oh, Ravi's pole. I can see it. Okay. So all of you kindly, you'll be unable to communicate because the link is muted for all students. It's for the sake of our own security, so that we have it. So allow us to proceed with the way it is. That Jen started. So I was saying that there are two forms of heat transfer here. One, it is through the vibration of the particles, what we call lattice transition of energy. And then number two, there is through free electrons transfer. So there are two, free electrons and lattice vibration or vibration of atoms. Those are the two. So kindly spend more time to putting down the answers so that you don't keep on raising your hand. I think that's okay. So those are the two ways the heat will move from tea or from the hot liquid through the spoon into the until it reaches the hands of the holder. So two, free electrons and also lattice vibration or the vibration of atoms. Though the second one sounds chemistry, but again, it's still in physics. We also allow that one because it happens. When electrons gain more energy, they vibrate in their own fixed positions. And of course, through that, those atoms, they'll transfer that energy that they are gaining. So students, that is it. We can go to question number 7. And this one, I want to give you time to draw it. It is a very good question, very difficult for many students. Please have a sketch so that when we start discussing, you are okay with it. This is a combination of turning effect of a force and equilibrium. So just sketch it very fast. Then we discuss together. Okay, I think that time is enough for you to have just done a rough sketch. So determine the value of F. Now, students, when I look at this one, first number one, I need to identify, I need to realize that this system is in equilibrium, therefore it's going to balance. But as it is, if you look at consider the force given there and where the pivot is, it may not balance because of the imbalance, because of the forces. But it is balancing now because of what? Because of the mass. Therefore, the weight will always act from the center. Once you have been told that knee is uniform, then if it is uniform, the weight will always act from the center, that's the COG. So the weight of this metal bar, will act at 1 centimeter point mark because the total is 200. So what I need to do is to identify where there is 1 and say maybe 1 is here. So if this is, sorry, 100, not 1, but 100. If this is 100, then I have my weight acting from here. So I'll have my W here. So with the W there, then you are okay. You can proceed and do the calculations. This will be my D1. And then this one can be taken to be the weight. Remember, it is 150 grams. So I need to convert them into newtons. So I'll have to take 150 divided by 1,000 times 10. That will give me 1.5 newtons. So the weight of this thing is 1.5, which is acting at 100 Mach. Then at that point, then I can proceed and just take moments about the turning point. F1 D1 is equals to F2 D2. Now that I have F1, which is 1.5, D1, which is now the difference between 100 and actually this is you need to get 100 and what in between 100 and that is minus 75. You get the D1, then you proceed and multiply times D2, which is 75, then times F. And again, we've always insisted that when you're working with this question, please use the SI units. Don't substitute centimeters. Use the SI units. I know at the end of it, it's going to cancel out, but it's advisable to use it in meters. Use it in meters. Use the meters, going to get it right. So when you do that, F1 D1 is equal to F2 D2. And this is a marking point. F1 D1 is a marking point, especially if it is 3 marks. If it is not, then the first marking point will come at the substitution level, then the correct answer, the correct units. So this is a numerical problem, and you need to know where the marking areas are. The first one is for the formula, that's for the 3 marks. If there are 2 marks, then of course we forfeit the formula mark, we go to substitution, then finally the correct answer. If you do that, then you're going to get it all correct. So the correct answer here in the formation is 0.5 newtons. Again, because we are learning, and as we also progress with our studies in physics, remember, we have the do's and the don'ts in physics. For example, you are not allowed to leave your answer with the wrong units. If you, for example, if you write 0.5 kilograms, that's a wrong unit, then you lose a whole mark. So I'm also encouraging learners, if you don't know the units, then just leave it that way. Leave the answer to be 0.5. You can be sure that you'll get a half a mark of that. Unlike when you commit a wrong unit. So always make sure that you have the correct unit. If you don't have it, then please leave it open. Don't commit a wrong unit, because that one will attract a penalty of 1 full mark. So the correct answer is 0.5 newtons. I think I've already addressed the issue of raising hands. For those who are raising hands, you'll not be able to speak. So let's just follow the screen. And if possible, you can also be taking the screenshots so that you can maybe do the backup of your notes when you'll be free.
Okay, Mr. Libendi.
Yes.
The part where you place the pivot at 100 centimeters.
Yes, yes.
That's where the mass of 150 grams acts, or 1.5 newtons acts.
That is where the mass acts. You see, mass is the same as that's the weight of the weight of the rod.
Okay.
So it will also act from the center when the rod is uniform.
So if it's uniform, we have to place it at the center.
At the center, exactly. If it's not uniform, then more information will be provided so that you're able to calculate the center of the COG, the center of the point where the weight is going to act from.
Okay. Thank you.
Thank you very much. Okay, I can see some of us are able to speak. I don't know why others are not able, but it's still okay. Let's see. Okay, let's proceed. Thank you. I'm lucky the Form 3 class, you're organized, and I hope people are attentive, and this is the way to go. Remember, we are the best. We are the best. Form 3s, we are the best. Okay, now the second question on that question is the reaction. Calculate the reaction. This is the question. Calculate the reaction force on the pivot. Calculate the reaction force on the pivot. Reaction force on the pivot, student, this one comes about the Newton's third law, the action reaction, where we say that for every action, there is a reaction which is equal to action, but in opposite direction. So I can see 26, 9. Okay. Okay, let us just continue so that you don't again over ask questions. but it's also good to seek clarification so that we move together. So for the action reaction here, students, we are supposed to know that all the downward forces are classified under action, and then they'll give us an upward force, which is now being called reaction, which is always act from the pivot. So at the pivot here, then we are going to have our reaction. That reactional force, which is it will be equal to, let me get an eraser first so that I can remove this. Yes, this one. So then let me get a pen. Okay, then. Okay, so this is the W. Okay, so I'm saying that the reaction force is the addition of the two. W plus F is equals to reaction. So remember, W was 1.5 and F we got 0.5. So when you add the two, you are going to get the answer to be 2 newtons. So the reactional force is always acting at the center, at the pivot, and is always direction the opposite direction of the action force. So the answer is 2 newtons upwards. Okay. I hope I'm not very fast. We are now on question number 8. Question number 8. Question 8, the diagram below shows an arrangement of 2 identical light springs. Remember, the identical, that's another thing. And they're very light, meaning they're almost negligible in terms of weight. Then each spring has a length of 5 centimeters when untouched and stretched. The total length of the 2 springs is 15 centimeters when supporting a load of 2 newtons. So the question is calculate the extension on each of the spring. Calculate the extension on each of the spring. Now this is about Hooke's law in Form 2. And Hooke's law, all of us, again, some of us, we are having issues. But this formula of F is equals to KE is a very powerful formula. KE. It's a very powerful, sorry, it is normally is small. It's a very powerful formula because it is the one going to guide us that provided the elastic limit is not exceeded, then all the springs will have to obey Hooke's law. And when I'm asked to state Hooke's law, please don't use S, don't say F is equals to KE, because there is a condition that must be mentioned in the explanation, which cannot be featured in the diagram, in the formula. The condition that provided elastic limit is not exceeded. That one you cannot see it in the formula. And that's why we are not accepting students who define or who state the laws using equations. I hope I'm clear on that. So from today, kindly, if you're asked to state the law, you state a principle, don't use the formula. Don't use the formula apart from the principles of moment. That's why we now allow you to have F1 D1 is equals to F2 D2. But on this one, you must give the statement. Even with the pressure, definition of pressure, don't use formula force over area. Make sure that you use the statement, the words. So in this case, let's go back to the question. The total length of the extension, the total length of the 2 springs is 15 when supporting a load of 2. So remember, from here, we can get an extension, which is given by F over K. But now we are lucky that these springs are in parallel, are in series. So let me, sorry. Let me, I wanted to get a pen, an eraser first. So remember, these springs are in series, and there is a combination of getting when springs are in series. When Ks is the spring constant of the series is equals to K over N. That is for the series, that where N is the number of springs. So it means that if I want to get the spring constant of 1, I just have to divide by N. Now, if the springs are in parallel, therefore Kp is always given by Nk. I know these things are not in your syllabus, but we test them in the normal exam. So maybe some of you are not taught this, but we are given a very simple arrangement But now it comes to exam, we'll always give you this. So we can use those two formulas to try and bring out the understanding of the springs in parallel and the springs in series. KS stands for series, P stands for parallel. N number of springs. If you have 3 springs, just multiply times 3. If you have 2 springs, just multiply by 2. So in this case, we have 5, 5 each length. Then they ended up giving us 15. So meaning there was an extension of 5. And since it was an extension of 5, and remember my formula, it is the spring whatever, then I just divide by 2. So therefore, each spring will have to extend by 2.5. So that is how you're supposed to go around about the question. Good. So that's about the Hooke's law. And the question was a nice one. It wasn't a bad. So remember, quite a number of students who did this paper, again, they were unable to figure out that issue of 5, 5. They were just taking 15 divided by 2 to get 7.5. That's dangerous. Remember, 5 of it, 5 is the length of this unloaded spring. So you have to take the 2 length from the total extension, which is 15, then you divide by 2 because the springs are 2. If they were 3, you divide by 3. Hi, the combined spring constant, I think I've given you a formula here. The combined spring constant, now you can see the Ks, which is given by K over N. So you will be required to find the spring constant of 1, then you proceed and divide by 2. So that formula again plays a very crucial role. And in your book and syllabus, it is not there, but the questions keep on coming, even in NEC. So you have no choice but to teach you this, even if it's not the syllabus, but to make sure that you follow and understand. Because there's no learn springs without applying. You learn so that you're able to apply. So the correct answer there, then you are allowed to give it 0.4 liter per centimeter or 40 liters per meter. That one is allowed. So again, the examiner for this paper was a bit mean with the marks because a calculation is supposed to earn 3 marks, but you can see it was very mean with the marks. It was only giving 2 marks, and therefore we allowed him to do so because that was his day. But expect if anytime you get a calculation question, especially where the formula is involved, then expect to get 3 marks. But again, all in all, even if there are only 2 marks, please, students, always write the formula for your auto safeguard your own working. Have the formula, substitution, then the correct answer. That is it. So let's proceed to the next. We only have around 34 minutes. Time is running. I can see the hand is up, but I don't know how to. Somebody saying, what is he saying? Okay, I got the message. Students, let's go to the next one. This is a question on Bernoulli's effect under the fluid flow. This is a topic that, again, we normally do it in a hurry because it's towards the end of Form 2. And some of us maybe have not finished syllabus. Now we're also under pressure to deliver. You've realized that maybe some of us teachers, we are very fast on this. And quite a number of students are struggling in this topic. Please create time and go through it. At your own free time, you'll realize it's not difficult because, again, this is for aviation and it's a good area. It's a good area, fluid flow. So the diagram below shows an aerofoil moving in the direction shown in air at a high velocity. State and explain the direction on the force acting on the aerofoil. The things I want to mention here from the examiner's point of view. When the question is state and explain the direction of force acting on it. Now, you must state before you explain. So you'll have to say the airfoil will move upwards. Then explain why it's going to move upwards. Don't explain without stating. And don't state and leave it there. Because if you state and explain, it means that the 2 marks are tied. You cannot get a statement mark without an explanation. So, and there's no way an explanation will be correct when the state is wrong. So understand those dynamics in marking so that you get why some of us are not getting 80. But for this end of the term, I saw people getting some good marks, 70 and above will get a number. I have a lot of A's, so it means that We are good. We are ready for this, and we can do better. So here you state the direction, which is upwards, and then explain why the aerofoil moves upwards. And understand that when the aerofoil is being raised, what happens is that the air above it is moving at a very high velocity. And that increase in velocity above corresponds to a decrease in pressure. So pressure below it is higher than pressure above. That one will create what we call drift force or lift force. That drift force will make the aerofoil to be lifted up. So the velocity of air is higher above the aerofoil, creating a region of lower pressure. Velocity below is lower, hence a greater pressure. Then pressure difference causes the dynamic lift or the dynamic lift or the drift force being created. So utaipata ikienda juu. Now in this question, because we are comparing two things, there is one pressure at the top and pressure at the bottom. Therefore, there is a language that we need you to capture. You must be able to bring out the language, the comparative language. When you say higher, higher is a comparative one. You are comparing with something else. But when you say high, it is not comparable. Therefore, learn how to use comparative language so that you don't just say high or low. It should be lower. Lower is comparative. Higher is comparative. That is it. So, and if it happens, you need to draw a force. This is something that was also noted. Most of us were in a hurry during exams, and you do draw very funny diagrams. If you are drawing a force, make sure that the force is touching. That line must touch the object. Number two, it must be using a ruler. It must be a straight line. So draw a line that is very straight and let it touch the object for it to be qualified to be a force. Okay. So comparative language there was being tested to see if the learners are able to remember or to compare things correctly. Okay, I just looked at it that way. I wanted to ask, I don't know if quite a number, some of our classes, there's a hand up. Moti? Who is Moti? Okay, so I never have to unmute. That's okay. Let's proceed with because we have around maybe 30 minutes, actually 29. Let's work so that you finish on this. I was about work energy and machines. I don't know if you've done it, but this is a question that you can easily get when you get a graph of force against.
Okay, I was asking, can you come again?
Where, Wapi? Which question? The previous question.
Yeah.
Okay. This one. I just said that when the aerofoil is moving in the direction provided, given on the left, then air above it, because of its shape, the air above moves very faster than air below. And I'm saying there is just mute so that I explain to you. So I'm saying the air above moves faster than the air below. And due to that velocity higher, which is higher at the top, it will lead to a corresponding decrease in pressure. So at the top, there is low pressure than at the bottom. So the difference between the pressure at the top and the bottom creates what you call pressure difference. When you get that pressure difference, it will result into a drift force or dynamic lift. So dynamic lift is caused by difference in pressure. Then the aerofoil will be lifted up. That's how the plane gets airborne. Okay, I think now it's okay. Jeremy?
I wanted you to kindly repeat on how to label the forces, that is.
Oh, thank you. Yeah, those are good concerns. That's why it's also good to, maybe I was in a hurry. I said that in case you want to label a force like on a body or an object, like for example, what I'm having here, make sure that you use a ruler, number one. You draw a straight line using a ruler. Then number two, make sure that the force is touching the object. Like you look at the force at the top, it is touching the aerofoil itself. it is not in space. The force must touch the object so that there is, because if the force hangs in space, then it is not acting on the object. So those are two areas we need to consider. It must touch, it must be in contact, and then number two, it must be a straight line using a ruler. Thank you. I think we can go to the next. I wanted to look at the question on Tikka timer. Because I know, and then being term one again, quite a number of us are still struggling with linear motion, especially when we were deriving them. We did them in Form 2. I remember like the former, was it Form 2 Dayton? I did it when they were in Form 2 and they were like, what are you doing? So, Chief, can you first rename your whatever, remove that Chief before you speak to us. So, students, a question on Tikka timer or linear motion at large is a very good question. And this is normally free marks for many students. Lakini sasa you really have to prepare well. So when you are at home, please go through the linear motion, the whole topic, understand the derivation of all the equations. Starting from the first equation, V is equals to U plus AT. Second equation, S is equals to UT plus half AT squared. Third equation, V squared is equals to U squared plus 2AS. Understand them. Then on how to derive. From there, proceed and go to free fall, where now A changes to G. Then from there, go to vertical projectile, where now G changes to minus G. The same equations, just simple manipulation. Then come to horizontal projectile, where we have range. Range is given by UT. R is equals to UT. But remember, T is the time that's treated for the free fall, for the body to move from the vertical height downwards. So that's the summary of all the formulas. Then remember there's what you call, there's a time of flight and also time taken to reach maximum height. All those things you have the notes. Please go through them and understand on how to use each and every equation, so that once you get a question, you can now apply the correct formula. The question I have here, number 11, section B, is the setup below was used. It shows a Tikka timer that was used to determine the relation due to gravity at Moi Girls High School, Eldoret. Briefly describe how the setup can be used to determine the value of acceleration due to gravity at the school. So they just wanted to explain, to give a procedure. If you are given this machine in that physics lab, what are you going to do in order to determine the gravitational force of gravity, the force of gravity in Mangu High School? So this is a question that requires a learner to have the understanding. Akuwa naelewa kile anafanya, or else you will not have it easy. So I'm looking at this. I don't know who can try, if there is any who can try. Anyone who can try? Because this is a described question, 3 marks. Who want to attempt? Because I've heard some of us are able to speak. 63, 26, 333. What's your name, please? Because you're a frequent student, speaker. $26 333. Okay, I think he raised by mistake. All right, so let's proceed. I really wanted that one of us to at least to. Are you able to speak? 26 333.
Okay, this is just an attempt. I'll
Yes,
say that
relax. Your name?
Kingston.
Kingston.
Yeah,
Okay, from which class?
the Cambridge.
Okay, Cambridge. Thank you, Kingston. Proceed.
Okay, I'll say as the weight acts on the Tikka, as the 100-gram gram acts on the Tikka timer, it slowly starts to go down, indicating that acceleration increases due to the force being acted on the Tikka tip.
Okay. I like it the way you started saying, but this is just a trial. Good, Kingston. Larry, the last one, maybe I can allow, so that then we can have a conclusion on this. Thank you. Larry or Denzel. Denzel, I can see your hand is up. She's here. That is Duke.
Well, we can say that as the 100-gram mass is being placed on the ticker tape, as it is being released, the 100-gram mass will start moving down due to acceleration of gravity, which will we can say the marks on the ticker tape, and we can use those marks to calculate the acceleration, and from that we can be able to get the acceleration due to gravity in the school.
Okay. I get it. That's Denzel. I like it the way people are becoming creative. I don't know if I can get the last one before I give my version. There is a hand up 26,657. Speak your name.
I'm excused, sir.
Yes, how are you?
Oh, fine. I had raised my hand previously. I had been unmuted. I wanted to try.
Okay, proceed.
Could you say you first measure the distance at the start when the mass is gaining velocity, and then you measure the maximum distance on the ticker tape.
Okay.
Then you get the difference between the velocity. You calculate the velocity at both points, and then you get the acceleration through that.
I get it. Allow students, let us know. I think you can, I'm happy with the progress. Maybe I can see Terence Gitau. That's the last one. Then I respond on I also give my thoughts. Terence?
Yes.
How are we going to respond to this question now?
We collect the values of the distances between the ticker, the ticks on the ticker tape, the corresponding values of the time between the time for the distances between the ticker. So we plot a graph using the values. The straight line passing through the origin. Then we conclude that the acceleration
is the slope.
Yes, the slope.
I like this. This is what we call creativity. This guy has gone to the extent of plotting a graph. Students, allow me to go back. Let's go back to the diagram. Terence, thank you very much for your contribution, Kingston and Shisia Denzel. Emmanuel, I think we can, because so far the three who have given out, there is no, unless Emmanuel you have the right answer. Manu? Okay. Allow me to share with you what I think need to happen here. Let's go back to the question. All that you've said is true, is supposed to be happening in the practical, but now we are not responding to the question. The setup below shows a ticker time used to determine the acceleration due to gravity at Moi Girls High School. Briefly, that's where we start from. Briefly, describe how the setup can be used to determine the value of acceleration due to gravity at the school. Looking at this question, remember acceleration is a change in velocity, rate of change in velocity. So when I looked at the question, first you are supposed to, you cannot start working, you cannot start running without switching on the ticker timer. So the ticker timer is switched on and let the mass fall freely. You switch on the ticker timer, then allow the mass to fall freely. Remember the mass tied to the tape. Then remove the paper tape and cut it into appropriate number of ticks. Then determine the initial and the final velocity, the final initial and final distances using the expression, velocities, using the expression v minus u over that t. That can be an equation is equals to a. You will determine the value of gravitational acceleration of the place in question. So the 4 marking areas I want you to follow through. 1, switch on the ticker timer and let the mass fall freely. Number two, remove the paper tape and cut it to appropriate what? Numbers of ticks. Of course, one of you was bring out that version. Then determine the initial and the final velocity. Then using that equation, v minus u over t is equals to a, you have your acceleration. So the issue of graph is not very possible. We cannot plot a graph, but it was a good practice trying to be innovative and thinking of how to can be able to do that. So basically, this is how you are supposed to determine the gravitational acceleration of the place when you are using the ticker timer, the one that we have here. And it was drawn very clearly. So that is it. The students in the waiting room, I don't know. Okay. Just admitted them. I hope they're students, but it's almost time. We only have 10 minutes. So students, I'm happy with that question, that actually described questions are bringing issues to very many of us. Please practice on how to deal with them. Most of us, we are practicing on how to deal with questions, calculation questions. Then you forget about the described questions. And that's where the examiners are getting us, because now they know we are not ready for described questions. They go and set those ones. Allow me to go this, I think it will be the last question, unless somebody has a question on ticker timer. If there isn't, then you can go to the last question. So far, I can't see any hand up. So meaning that we are okay. Good. So let's proceed. We go to the last question here. This question is about a block of wood of mass 40 kilograms is pulled along a horizontal rough surface with a force of 150 newtons. Then, given that the coefficient of friction between the block and the horizontal surface is 0.2, then calculate the frictional force between the block and the surface. This is a question in Newton's laws towards the end under frictional force, where you have mu, remember. And maybe I can just remind you that Fr is equals to mu mg. Remember that formula. So that's the one that's now required here. So I hope you have written the question, or you can take the screenshot so that you can look at the solution. 26755, your hand is up. I'm giving room for you to copy the question. Larry, your hand is still up, or you okay? Okay. Let's proceed. So I hope we are through now with the question copying. Now, when you look at this, you have 40 kilograms, that's the wood, but you're applying a force of 150.
Excuse, sir.
Yes, Larry.
The question that, this one we've done, I've gotten an answer.
The one for ticker timer?
Not this one, the block of wood.
Oh, you already have the answer?
Yes.
Great. Kindly share with us what you've done.
So I use the formula of friction is equals to coefficient times reaction.
Correct.
Then the reaction force on the block of wood is the force being applied minus the mass of the force of the weight now.
Good.
That is 150 newtons. That is the force of being applied for it to move along the horizontal surface is 150 newtons. So by calculating the reaction force, you take the difference between both.
Yes.
Now there's one point I wanted to ask the question. When you're calculating the reaction force, do you take the mass minus the force being applied? Because if you do it the other way around, it gives you a negative.
It gives you a negative, right?
Yes.
It is supposed to be mg, because remember Fr is equals to mu where the coefficient of friction, and then times R, reactional force, which is the same as mg. So if I do that, then I'm supposed to be having this. Remember, it was given to be 0.2, then we multiply times 40, then times 10, that gives you 80 newtons. So 80 is the friction, is the force that you applied, is the frictional force. Then remember we applied a force of 150. So from there I can now be able to calculate any other things. Is that okay?
Yes, thanks.
Thank you. So students, let us finish on this. So I'm supposed to find the FR, which is the frictional force, which is given by mu mg, then proceed and get the 80. But remember, we applied a force of 150. So that means the net force acting on the body will be 150 minus 80. That will give you the net force. Then from there, I can now be able to proceed and get acceleration of the block, which will be given by that formula. And then just say is equals to F over m. And the answer now becomes 1.75 meters per second squared. That is it. I think I hope I've not taken you very fast, but I'm very happy. I must say that the way the Form 3s are behaving, it is the best class so far, the best online class. And you should keep that spirit. You should keep that because you're able to discuss, you're able to raise your hand, and you're able to share your views, and you're able to relate well. 26604, your hand is up. 20, yes, you can talk. Declan. Declan, I don't know the name. Declan Rice. You can unmute and say something you have to say. The last, okay, it's not talking. 26874. I think some of us are struggling with the Jadon. Okay. So I think we can, let's proceed. So I just want to take you back to this. So that,
Excuse me, sir.
yes.
On the parts that we were finding acceleration,
Yes.
why were we dividing by 40 newtons?
Very
By
good, very good. Remember, F from the Newton's third law, F is equals to ma. Is that okay?
Yeah.
Where m is the mass and F is the resultant force. The resultant force was given by getting 150 minus 180 minus 80, which gives us 70. Because we are looking for acceleration, then we divide by the mass of the body. So we are using.
Thank you.
Thank you very much. We are using Newton's third law. Jadon, you have a hand. Your hand is up. Okay. Gabriel Jesus. Tom, I'm not addressing the questions before we end the session because we only have 5 minutes. So in case you have a question, it's free that we can address them. Tom? Okay. 26604. Okay. That's right. 26601.
Yes, I would like you to give the summary of most things that you've learned today because some of us joined late due to circumstances.
Pole. I'm sorry I may not be able to do it because the link expires in the next 7 minutes. And if I may decide to go back to where we started, I think we've covered for almost 1.5 hours. It's not easy. Maybe what I'll do, I'll share the paper that I was going through, I'll share it on the wall with their parents. They will be able to print the copies for you. I think that will do so that in case you have a question, you come back to school and raise. Thank you. Weningo? So 26601, kindly mute. Okay, thank you. Okay. 2600604. I think I'm finishing on this. So if you have a question, just ask, so we're able to clarify.
Can you repeat? Excuse me, Mr. Libet.
Yes.
Would
Yes.
it be possible?
Would it be possible
to basically go through some topics? For example, Newton's law of motion at the next physics lesson.
There's no, in fact, those are good recommendations. We can pick it that way. If that is a majority, will request, have no problem. So what you can do, you can raise it through the wall. I think the areas you want us to address, we can be able to address them. Then I can organize for a session or spell on that Newton's laws, so that we can discuss the whole topic. So I can prepare that one for next time. Thank you very much. Sangdi Wu. Okay. Students, I think I'm looking at the time remaining. We only have 6 minutes, and so we have one request from one of us here that we do Newton's laws. I think that can be considered. Khalid, do you have something to say? Said. Okay.
Excuse.
Yes.
Can you repeat the last question? Explain.
Okay. We are here on the last question. Okay. So the one of us again is asking about, I think the question that we are doing, one was about frictional force, which we said the formula is very clear. Fr is equals to mu mg. Mu is the coefficient of friction. That is one people are missing. That's why they were getting a negative. If you miss micro, then you end up getting a negative. But if you have it there, then the answer is 80. Then 18 is the force that is being wasted on friction. Then because you are applying a 150, the difference between 150 and 80 will give us what we call the net force. And that's the one that will make the body to move. And then using Newton's third law, F is equals to ma, now we can proceed and get acceleration, which is now given by resultant force over mass. And by so doing, the answer is 1.75. Students, I want us to stop there. It's already it is 10:27. And I'm going to take into consideration whatever that you've raised. In case there is something, maybe you can also raise maybe through the parents, they can be able to show on the wall, so that once you agree that that's the topic you are doing, there's no harm. I'm always flexible, I can also go through it together with you. I want to wish you well as you take a break back at home, but remember to maintain, to continue being good students, and please revise because it's the best way. Remember, now we are going to Form 4 come next year. We have no choice but to set the pace. Kila naheri, may God bless you. Bye-bye. Okay, Mr. Ashira. Mr. Ashira? Oh, it's not in.
Yes,
yeah, I've come to the end of the session. I've just closed the ended the session. And Form 3s are very good students. They are very good. They are behaving well. You'll give me the recording after this, kindly.
You'll get it on
thank you, sir. Good day.
Food is also a body.
Aye.
In terms of both,